Okay, so I'm sure again you were kind of ticking away in your head. As I was going through these lists of I don't like that, I don't like that. Here's the problem with that. And the problems are not hard to understand. If we get into the specific engineering problems, that's not really what we're after. But that is also true, right? So, if we try to think about these unmanned drones, okay, well, how are they fueled, right? Are they fueled with a bunch of batteries? Well, if they are, that increases the weight. And they have to get the fluid up there, right? So we don't really have planes that fly around in the stratosphere, other than maybe like the U-2 spy planes that we've could have used 30 or 40 years ago. The tech exists, but we're going to really steer clear of those engineering things, right? I'm not sure what frothers on a ship would look like. I've got my coffee frother over here. Maybe it's just a giant coffee frother. Now I want a cup of coffee. Okay, so the biggest problem of all of these is the biggest problem with climate change, right? So CO2 is the primary thing that we've been concerned about. We've been talking about carbon for weeks and weeks and weeks now. What the heck, right? So all of these are band-aids, right? None of them deal with the problem of CO2. And that kind of in and of itself is a problem, right? So if we invest all of this money doing this solar geoengineering and building our space shade and these mirrors and frothing the ocean and all of these things, are we less inclined to then reduce CO2? Because again, that's the underlying problem. And we'll see that's actually tied to a couple of other problems with solar geoengineering. Okay, so hypothetically, let's say we decide as a planet, right? At the UN, we decide we're going to do this project for 10 years. So we're going to do all of these things. We're going to put our sulfur dioxide in the stratosphere, reflect all these things, and it works. And it starts to cool off the earth. And then something happens, right? For some reason or another, we have to stop the program. We'll see there actually might be reasons why that could happen. And then what would happen is essentially in about a year, or maybe even less than a year, that sulfur dioxide would strip out and we'd be back to normal. But in that 10-year period, we would have increased the CO2 of Earth, right? And so now we're kind of like jumping back to where we would have been rather than experiencing this kind of gradual change. Because as the CO2 is rising, we artificially kept temperature linear in a sense, hopefully kind of flatlined temperature, but CO2 continued to rise. But those two had a divergent point, right, where that started, right? As CO2 is going up, we kept temperature here. But once we've stopped this mode, now those two are out of sync. And we could potentially see lots of problems in a very short amount of time. So what we would call termination shock. What happens when we stop, right? So it's pretty difficult to continue something that you have to do for the rest of human existence or until we figure out a different way to solve this. So obviously that's a pretty big problem. So world powers, again, those are kind of swinging a heavy hammer over at the UN. Well, when we had Pinatubo, 92, one of the things that we saw is, yes, it dropped the temperature of the Earth, but it had a lot of other effects. Things that changed monsoon duration, monsoon intensity, and global moisture patterns. So those largely affect places that are kind of on the margins, or a little bit more on the margins. Developing nations, Africa, sub-Saharan Africa, India, and China. Those are big nations. But one of the things that we would see is that if we start doing this, and it has these unintended consequences, I think a lot of people would say, well, it's for the greater good. But that's a terrible argument if you're the person being affected by that. You're saying, well, it's not good for me, so screw you, right? I don't want to do this, which can ramp up, international tensions. If there's less snow falling in the Himalayas and we don't have, snowpack, and we don't have that water, the Indian subcontinent, 1.5 billion people are going to be angry. So there's potential conflict, right? Again, we would have to have global scale buy-in, where is that's one of the biggest challenges in climate overall, right? Is that to do these things, really everyone has to be on the same page, because if you're negatively affected, at least you are in and supportive of the idea. So the other consequence, the other problem is if we put the band-aid on, right? If we stop warming, well, we'll potentially get less emphasis put on changing our behaviors, right? So again, I kind of talked about CO2 rising and keeping temperature at this flat line. Should be drawing a graph rather than doing my arms here, but whatever, you get what you get, right? So if we're increasing or like not changing our behaviors or not doing these other things because this solar radiation management has kind of worked, that drives the two even further apart, right? And so that makes us so much more dependent. And again, the other big thing, thinking back about CO2, we've just been focusing on heat, right? Heat is only one aspect of climate change. One of the other really important things that we've talked about is increased levels of CO2. Well, that CO2 will diffuse into the ocean and reduces the pH of the ocean, again, increasing the acidity, and can cause extinction, right? It can wipe out marine life. We've seen that with corals and coral bleaching. So even though solar radiation mitigation or kind of limiting, the solar radiation management levels, there's still a lot of other problems that aren't addressed. So it's probably important to do this, but it's also really important to think that that can be a little bit of a stopgap measure while we're doing other things as well, right? So we're not just going to go all in on saying, oh, put on the sunglasses and we're good, because all of the other problems are still going to continue to be problems, right? Earth's ability to kind of consume CO2, us taking slow carbon, emitting that into the atmosphere. All of those things need to also be addressed for this to be realistic. So what are the benefits? Well, first of all, we've cooled the Earth. We can use solar radiation management to make the Earth a much cooler place to go. We're going to need a really big pair of sunglasses to put on the Earth, and maybe a cool new haircut or something like that, right? But it works, right? It will cool the Earth. And so it can modify or limit some of climate change's most kind of dominant heat-related effects, right? And so, again, we've kind of mentioned that poking on the system can cause some problems. The other thing about solar radiation management is that it would have a really quick effect, right? So this is something that if we had our bits and bobs all put together, we could do this and deploy this in a couple of years. If we were to slow down the rate at which we're releasing CO2, which were this kind of part of mitigation, right? That takes a long time to have effect, right? So you could also kind of think about, I'm going to draw graphs with my hands again, right? As we've got this long arc in changing our CO2 system, right? Kind of producing less CO2, changing the way that we do energy, increasing carbon storage, maybe carbon capture and sequestration, some of those things. That's going to take a long time. So this could be a very reasonable thing to deploy to limit warming in the immediate future. But again, it has all of these strings tied to it that are potential downsides. But the benefit is that it's something that can happen really quickly and would have very kind of immediate effects. So again, following Pinatubo, the next year, the Earth was cold, right? It was cool. So it's something that can happen quickly and can have immediate effect. Again, focusing on sulfur dioxide, because it's probably the most realistic out of all of these that we've talked about. The other big benefit is that, again, when we saw from Pinatubo, it has fairly low residence time. So that CO2 will strip out of the atmosphere if we don't like it, right? We do it and we start to see some changes. It's not like we're stuck with those changes for decades and decades. If we stop the program, we brought our fleet of drones down, we pulled our balloons down, or whatever the heck that we did to put sulfur dioxide up into the stratosphere, things would go back to normal pretty quickly, right? Again, maybe a year or two. And that's a pretty big benefit. Um, okay, so again, there's a lot here, right? And I didn't go through all of the kind of, all of the gory details, particularly we left the engineering stuff out. But that's a quick rundown of what solar geoengineering is all about. The next thing that we're going to get into is really how are we going to reduce carbon in the atmosphere itself, right? How can we actually remove carbon? So active removal. That's kind of the next big category within geoengineering. All right, I'll see you then.